Jay.
All right.
Oh, we're live. Excellent. We got JU, VP of Applied Research, Graph Engineering, Relational AI. This is following up on our killer conversation about Blue Yonder and Snowflake earnings, and the way that they were described in that earnings call, I thought was just exceptional. But even more exceptional than that was your description and your conversation with me in around all things Blue Yonder, but also AI in general. And here we go. We're going to have a much longer environment for us to talk, not 8 minutes. We're going to go, 30, 40, maybe even 45 minutes, Jay.
Okay.
I know you got it in you. So by all means, thanks for joining. And here we go with a LinkedIn live session. So thanks for being here.
Thank you, Alec. I had a blast last time, even though it was 8 minutes. We had a lot to cover, and I feel like we had a lot more to share. So thank you for giving me the opportunity to continue the discussion. Again, this is a free-form discussion. I'd love to, drill down more about, AI, everything enterprise. I think that's really something I'm passionate about, and I have a lot to share from my experience and also the current project I'm working on.
Without a doubt. So let's do it. And with your background, which I am so impressed by, and our conversations, have been some of my favorite, in and around this idea of enterprise AI adoption, transformation. These are not easy things to get done, especially when you're talking about mission critical applications and infrastructure, et cetera. And you've got a whole lot of experience and perspective in these areas. And so I'm just going to give you the open-ended floor question, Jays. When you think about enterprise AI maturity, and some companies, some research reports from some of these major management consultancies suggest that the largest companies in the world, maybe 4% of them are quote unquote AI mature. And why do you think that is? And what do you think some of the challenges and opportunities are when it comes to enterprise AI transformation?
Well, that's a big question. That's a great question. So first, before I answer that, I want to share a little bit of my background.
Yeah.
Really can help people understand my perspective. I started as an academia. I got my PhD in computer science, but on a very practical, large-scale database engine in the late 90s. And then I went to work for Teradata, one of the biggest, data warehousing company. Back then, they were able to handle terabytes of data. They were a warehouse. That was like 30 years ago, right? But then I feel a little bit bored. I decided to go to the other side, which is I joined a startup to work on B2B e-commerce. And pretty soon I landed at Intuit, one of the best personal finance or enterprise, actually small business finance companies. Wonderful company. I spent 18 and a half years there. So there I learned a lot about how enterprise adopt technology. I myself, being one of the driving forces, actually managed to figure out how to use knowledge graph technology to modernize the TurboTax software. By the way, the tax deadline is coming. If you use TurboTax, think of me as well. I see a little bit on the back-end engine, but long story short,
you're right there with us. You're with us, Jay.
Yeah.
Right as we're getting through it.
I need to do my tax as well. I'm not immune from that. But anyhow, through my 18 and a half years there, a big significant time is figuring out how to have Intuit adopt state-of-the-art knowledge graph technology, how to make it real, how to make it really work for a mission-critical application like TurboTax, right? And then also later on, also take on the challenge of enterprise data, how do we integrate silo data together? So long story short, I learned a lot about in enterprise, what's most important, how do we deal with technology? So AI, as you just mentioned, the AI maturity is a brand new thing. Even before AI maturity, there's things like a data maturity of the company, right? Technology stack maturity. It's all related. Now, if you're not data mature, you're not technology mature, jumping on the AI, you'll have a lot of challenges. But let's put that aside, right? So any great technology, like where we experience firsthand how powerful Gen AI is. Gen AI, to me, I personally use on my daily work. Also, I'm on the advisory board for a small startup in Gen AI. I try to create a no-code, a chatbot platform. You don't have to learn any coding. You can create chatbot, can be grounded. It's RAG application with GraphRag and so on and so forth. So I learned a lot. AI is extremely powerful, extremely, it's huge potential. Using it right is going to help a lot of things. So in terms of AI maturity, I think about the following, just like it was laid out. Do we understand what this new technology is really about beyond the hype that's going on, right? Part of that is, do you know what kind of use case are the best for Gen AI at the current stage? So understanding where Gen AI is, what kind of use case it shines, is the first level to assess whether you have AI maturity or not. If you're only following the hypes, jumping on hoops here and there, there's a long way for you to understand where you are before
Watch
you
out.
get. Yes, that's really true because as you know, I'm sure all the top level executive is want to invest in AI, want to make sure that AI can help company. There's a few different angles. What Gen AI is really good. First of all, the actually 3 4 years ago, maybe 5 years ago, when I before I left into it, I'd led a small R&D team, a few PhDs. That was the GPT-3 just came out. We used GPT-2, was open source, try to figure out what to do with it, right? And then back then we learned is one task we know the GPT technology goes really well is be using its creativity because it's generative. So one of the early success prototype and to get real traction for adoption was for marketing, creative marketing. And we quickly built a tool and then we show marketers. Marketers say, this is great. Suddenly with a click of a button, if I just do some prompting, it generates all kinds of ideas. I can ask it to come up with a wacky idea, come up with really, normal idea. Of course, I can do that, but it take me a lot of time. But suddenly, this tool gave me instant access, and this tool does not need sleep. So that's a early indication is, do you know what use case you want to do? And then what Gen AI is really good at, you find a match, that's define your first success level. Again, that's really the one first thing about AI maturity is, do you know what this Gen AI can do? What's the best you can do? And then if you can attach this to that kind of use case, you'll more likely be successful. On the flip side, also there's a temptation about, wow, AI is so powerful. I want to throw it into the middle of my core product. I want to make sure my customer really use it. Now, in this case, you have to be really careful. Is that a for fun product or is that a mission critical product? There's a huge difference there.
I love where you go with that. It reminds me of a conversation we had had recently about. I mean, there's a couple different directions I can go with that to react, but one of the directions for sure is understanding the use case, understanding how to take the strength, which in this case, forgive me for saying it this way, but some folks get concerned with generative AI where it's not accurate and there's a hallucination and so on and so forth. That's fantastic as it relates to creativity, right? Because it's ideation and so on and so forth, and the humans are involved and can help prioritize, et cetera. But let's step into the mission critical stuff, right? Because I think that one of the things you and I spoke about recently is that the decision making around these investments, this is now towards the very top of the CEO's agenda, and he or she is asking a lot of questions of the technology team, but the operations team and everybody coming together, but especially around mission critical applications. And I know you've got a lot of experience with the mission critical dimension, so I wonder, could you help us understand, what you think is possible today with mission critical applications being addressed by world class AI systems? And I'm talking about like what's really possible, not to suggest that we all can just go out there and do this, but I want to open up some people's eyes to where we really are if and when certain circumstances are met with mission critical applications and the way that these AI systems can really do some pretty exciting things today.
Yes, that's a great question. First of all, I also want to make a disclaimer. This is only my personal view.
Yeah.
Then the company,
It's not your t-shirt view. I
yeah,
see what's on the t-shirt. This is your view.
and also the it could be controversial, which is that's why I'd love to open that up. If
Excellent.
people
Let's hear
don't
the
agree,
point of view.
please,
Absolutely.
yeah,
Here we go.
absolutely, we love to, right? So I think that from my point of view, this mission criticalness for AI is absolutely the key, right? Understanding there's no 100% hallucination free software. If you hear any advertisement like that, you need to look into that because there's no such thing, at least not right now. So then the question is, how do you bring that to as close as you want? So at least from my experience with TurboTax, with Intuit's financial software, there's zero tolerance for error.
Right.
So that level of mission criticalness is really, really hard to accomplish, but there's still a few ways to do it. So the question is, can you ground AI? Can you control and tame the AI beast? It's very powerful, but it can kill you if you're not careful, right?
It's powerful
So,
stuff, like a car, car can do
yeah,
it too.
so there are a bunch of practical techniques. This is where when you talk about AI investment is understand where the Gen AI technology LLM is, but also understand what is the advancements there. Try to doing some prototype to understand how to bridge the gap. So of course, one area is RAG, retrieval augmented RAG, retrieval augmented generation. The idea is all the knowledge trained by LLM is all over the place. It's not very domain specific. Can you ground the answer by the domain knowledge you have? So this is where we're infusing human knowledge, expert knowledge, or ground truth knowledge with LLM by having first, the technique, the common techniques initially was vector search, right? Given that you have a lot of documents, you say, hey, LLM, don't use your knowledge, use my knowledge. But how do you provide that knowledge? Unless you have unlimited budget, you want to train the LLM completely on your domain. Otherwise, you just augment it with all the document you index with vector search, and then you do proximity search, semantic search, find the most relevant parts toward the person's question, and then you provide as a context to the LLM. Now, with these knowledge sources, construct the answer truly based on this. Don't try to do your own. And then part of that also, when you generate that, you instruct AI to say, don't hallucinate or stick to the truth. One of the areas you can do is making sure the answer generated has a reference. If an answer generator has a reference, at least there's a traceability lineage towards the knowledge being used. That's one way to check. The answer is not out of hallucination. It's backed, grounded by certain references coming from the source doc. So that's a typical technique everybody use called RAG. Now, when you do RAG, you can oftentimes also encounter limitations because vector search can be overwhelming. If you have a lot of documents, oftentimes the search result, you have so many hit, you have to cut down to the top 10, 100, or 1,000 in order to fit in the context window. By doing that, you also, unfortunately, have to eliminate, but by statistics, eliminate certain other, maybe more important material you don't know. That's why the answer quality may not be there. So then we come is graph rag. What is graph rag? Instead of doing vector indexing with a proximity search, rely on vector index, generate multi-dimension, like dimension of 24, 20, 48, and then do proximity match. Still don't understand the meaning. Just say, hey, based on this, we think they're close, which is by all. It needs also that function to generate the index is also controlled by LLM. By the way, there's a dependency there as well. Graph rag is just say, hey, why don't we build a knowledge? Why don't we have a knowledge graph? How you build a knowledge graph, there's different ways. If an enterprise already have a knowledge graph, then you have a very precise knowledge about the domain. Now the question is, can you utilize that knowledge base as the input to LLM? And that will dramatically increase the answer quality and preciseness of that. So that's a few techniques. If you really want to go to the mission criticalness, you have to think, can I really trust? First of all, can I trust the base knowledge from LLM? The answer is no, because it may not understand your use case enough. Then I want to augment with my enterprise knowledge. There's two ways. One is I just keep dumping documents there, rely on the vector indexing to do that. Again, certain level. Let's say the what's a good score? Let's say accuracy level from 50% improve to 85%, or maybe less than 75%. But is 75% good enough for a mission critical app? No. Why don't we bring the knowledge graph in? And bring the knowledge graph, then can up the accuracy rate from 75% to 90% or even 95%. Now we're thinking it's progress. Now you can see my AI investment by using those technologies is leading toward the quality I need in order to fulfill my mission critical apps need, right? So that's really the progression. So part of the thing is about investment is understand what technology is out there, understand what layer of technology you need in order to constantly improve the quality bar, but also it's very important, you always have to have a good evaluation mechanism, cannot be manual, cannot be ad hoc. And combined with that, then you start having a good plan, say how do we reach to a point that I can use AI to produce the quality needed moving forward. Sorry, Alex.
No, that was. I didn't mean to cut you off there, Jay. You triggered me on a couple different levels that I want to jump into. So, big shout out to Nick the Greek, our colleague, who's speaking at the AI and Future of Finance conference at Georgia Tech later this week. But one of the things that he and I have talked about, and we're talking about here, live on this session, is this idea of domain expertise and how knowledge graphs that are then part of, let's just, I'm oversimplifying it, but an advanced, compound AI system, that knowledge can then be put to work in ways that, for example, the financial services community, tends to refer to sometimes as edge, right? Every financial services, community member and stakeholder and company is looking for edge. And one of the things that finance has a whole lot of, as you know, is a lot of research and a lot of information, a lot of really smart folks that have put that together. So I wonder, just going on the finance route a little bit, could we talk through just a little bit deeper when we think of, let's think of an investment bank with a bunch of research, right? Historical reports, some of it's more evergreen, macro stuff, some of it's more timely and specific. But bring to life a knowledge graph and how graph rag using, let's say, institutional knowledge of that variety could create value for a financial services company, which is kind of a preview of some of the things I'm sure that Nick is going to talk about, this week at the conference. But I wonder if you want to go there a little bit, just because we both have that finance background as well.
I'll actually, I would not steal Nick's thunder.
Yeah, please don't.
Different angle, right? Different angle on this. Just more broad. Also linked to our Blue Yonder example we talked about.
Yeah.
Right. So I think a knowledge graph is, in the simplest form, is really about transform the all the information about a domain, about all the document, into something. It is actually a graph of knowledge. So what does that mean? A graph is composed of nodes and edges. In this case, a knowledge graph, nodes usually represent concepts, business concept. What is a stock? What is a company? Company has, also have revenues. All these things are concepts, right? And then edge is relationships, right? So oftentimes we have used the word is, when we learn, we say connecting the dots. What is that? That is forming a knowledge graph in our brain. How does this concept connect the other one? Right? So when we have a document, have a lot of words in it, can we distill this document into the knowledge concept level? This document is talking about stock transaction. It's talking about causation from company's performance to its stock price, to its profitability. Talking about what are the different elements that could change, can cause that. Can we distill that into that level of knowledge? And then we attach facts to it, right? So that's that, so with that knowledge graph, with the knowledge graph technology like what relational AI is providing, not only you can distill that, but also you capture all these relationships, you can define rules on it. For example, one of the very simple example, you say there's a concept of person have date of birth, right? Those are concept and relationship. A person has date of birth, and date of birth has a value, which is a date. But you can derive some more facts out of it. You say, what is age? Age is the derived piece. It's based on the current day, minus your birthday. That's how it's a calculated field. So that's a simple rule. So we attach those simple rules to allow you to derive new things. You can think about, you can derive a lot of derived facts or inferred facts on top of the base facts, right, into this knowledge. And then you can go to another layer on top. You can say, hey, I want to, simple things, do computation, aggregation, or I want to actually under infer. For example, there's a parent-child relationship inference, really interesting, right? If J is a parent of Andy, and then Andy and Lawrence are sibling, then Lawrence is J's child as well. What is that? We're connecting more dots. We're deriving new fields. When we have all these things representing such a knowledge representation, it's extremely powerful, as if how our brain works. So then the question is, how do you utilize that in the context of AI? How do you combine with LLM? So this graph comes in. When user asks a question, right? Then first we do use LLM, try to understand the intent of that question. We pass out the question talking about these concepts. Your question covered those concepts and how they related in the sentence. And then we just apply that to translate to something to query the knowledge graph. Say which part of the knowledge graph talking about these concepts, talking about this person. And then we find their contextual relevance and bring those facts together and verbalize that into a text. And then feeding to LLM, guess what? It will generate an accurate but also very meaningful answer out of it because it utilizes all the knowledge in the system. And it give you a very precise one. If J has, based on the facts we know about J, talk about Andy and then Lawrence is Andy's sibling, J has 2 children. That's very precise. There's no hallucination involved at all. Anyhow, that's a simple example to see the power of infusing expert knowledge graph, together with LLM. That's where you can accomplish the ultimate dream about I can really rely on the AI.
Yeah, I mean, without a doubt. And it reminds me, I'm going to give you a little foreshadowing the next question here, but it reminds me of something that we've talked about regarding the transition from an architecture perspective, going from an application, centric architecture to a more data centric architecture. So just to kind of give you a little bit of a tee up on this one, because I agree, it is magic, right? The idea of these, replicating mental models and connecting dots and doing that at scale for a business is obviously extraordinary. But I wonder if you might help the audience understand a little bit more, because this topic is starting to come up a lot, which is this notion of if the average person in the average large company has to interface with, I don't know, X number of business applications.
Mm-hmm.
Unfortunately, from a user experience perspective, sometimes that can be a little bit frustrating, right? Because the experience in one business application isn't necessarily known to the other application. And so you as the human, you feel a little bit like it's disjointed, it's not as efficient as it could be. And so the result is you have a bunch of different applications that maybe have some silo data sets. To your point, the dots aren't connecting. And so in this more modern, and maybe we're all going to kind of go at our own pace, but in this more modern, or where we're going with the architecture becoming more data centric, where data sets are joining that maybe perhaps were siloed before, I wonder if you could kind of talk through what excites you about that idea and where that can take things, because I think some of the more modern companies out there are really starting to hit the gas on that architectural opportunity. But it can be a bit abstract, but you're phenomenal at explaining these things. So I'm going to stop and let you go, because that's why people are here, is to hear you talk.
that's a very fascinating area because in my 25 plus years experience, I worked on many applications, as you just mentioned. Typically, conventionally, application build tops down.
Yeah.
What does that mean? You say, I want to provide this product application to people. This is the user experience look like. Based on that, what data do I need? And what data I don't have, I have to bring in. So that's very usually it's one I would say TurboTax is like that. It's good for certain functional area. That's all you want to focus at a time. Very well. So I'm just use Intuit as an example. Intuit besides TurboTax has other application. Another application is a result of acquisition called Credit Karma.
Mm.
So Credit Karma is a financial app that allow you basically help you to get credit score, but I think the purpose is to give you a better access to financial product. So there's a lot of financial data needed. Again, it's a separate company. Also built this beautiful application, very popular. When Intuit acquired Credit Karma, one of the business thing is, would it be powerful to connect those two apps together? So that's an example of application usually built is very vertically, very focused, fit for purpose. But then again, I will not review a lot of detail, but the high level is the magic is the data. Now, if you think about this, in the new era, Intuit has already provided that. I'd like to have a intelligent chatbot break down the boundary between Credit Karma and tax. Doesn't matter.
Here we go.
Right?
Yep.
So well, how would you build that? You start from the bottom up. You say, what are all the data, all the knowledge about personal financial domain, whether it's being tax, whether it being credit score, whether it being financial applications, loans, available credit card, whatever, it doesn't matter. That's part of it. When I model this knowledge representation of the finances, I don't specifically think about a particular tax app, particular Credit Karma app. I think about what is the right knowledge representation to connect all these data together, to elevate those data. Of course, they could be initially still diverse sources or silo sources, but doesn't matter. I can build an integrated knowledge layer on top of it. Once I have that, then doing a tax application is very easy. Doing a Credit Karma like is very easy because you access all the knowledge. You just access subset of it. You project the integrated knowledge graph into a subset. You just say, I'll focus on that. Guess what? Then having that unified app is very easy because that app suddenly see everything. And then even better, can flow data easily from one to the other because of the intrinsic connection between them. So again, that's a good example of what is app-centric, tops down, very single purpose. What is data-centric? You start from data, but I would say data-centric is translated to in the new word is knowledge-centric. That's why relational AI, we're helping people to elevate their data to the knowledge layer so that you can support all kinds of AI workloads on top.
You nailed it, and you took the word. You can see me smiling because I was literally going to go there, and the idea of data centrality and relational AI being a Snowflake native application and the magic of that. And one of the things that we spoke about in our 8-minute fireside chat, right, was the wonderful articulation of the Blue Yonder, work that's happening that was highlighted on the Snowflake Q4 earnings call. But one of the things that you said to me, and I remember when I first heard you say it, where, and correct me if I'm wrong, because here we are live. I believe it was somewhere in the neighborhood of you looked at an enterprise, application and code base that had been built over years. And there's some accidental, complexity that happens over time and so on and so forth. But you were able to essentially reduce that to about 5% of the original size, extending the logic into an environment, knowledge graph, that could then be unpacking and enabling decision making at a velocity that was previously unimaginable. I'm sure I butchered some of that, but that's right. Okay. That I think we need to hear about that because that's like, whoa.
Now I can dive deeper a little bit there. Now we have more time, right?
Yeah.
First of all, the work is not my work; it's our work, and also it's done by a great team of OR research experts, many PhDs at Relational AI, partner with Blue Yonder. So the specific challenge we took on is there was a great application, but it was built more than 20 years ago,
Mm.
and it's trying to solve a basically supply chain planning. It was a desktop app and so on and so forth. By the way, all these information is in another public talk from the Snowflake Summit last year. So I'm not revealing anything proprietary. People can directly learn about it. But anyhow, so that application has about 400, more than 450,000 lines of code. More than half of it is related to business logic. Try to take a supply chain design and try to figure out the most optimal way for you to plan a supply chain. Okay. So our team took basically reverse engineer the app. Long story short, we literally took a knowledge driven approach, a data centric approach. We literally say, can we turn our data into a knowledge graph? And then can we use, again, when I mentioned, once you have knowledge graph, we can apply rules on it. Those are very declarative, easy to understand rules. We just use those declarative rules to describe how do you transform the underlying knowledge graph about what are all the variables matters for optimization, for an optimal decision about how you run your supply chain, how do you plan, right? And then we allow you to specify what are the constraints. For example, you can say, I have inventory at various stage of my stores or my factory, right? The constraint is I cannot exceed that inventory level. That's the limit. I only have limited capacity about resources. My labor resources could be limited. My machinery resources capacity. They can only generate this many goods, right? So the supply chain is a very complicated decision making because there's so many factors around it. So we give you very intuitively say, hey, I want these to be the control variables feeding to my mathematical optimization formula. Part of that, I'm telling you what are the constraints, min and max. But also you can derive more interesting stuff. For example, you can say, I want to calculate the total cost of the supply chain, but ultimately I want to put it into an objective function, say lower the cost. And also I calculate all the lead time, say what is the lead time usually for takes from the raw material all the way to finished good to a particular retail store. I want to minimize that lead time, right? But I still want to minimize lead time, but also I want to maximize profit. So we just, instead of this 200, more than 200,000 lines of code, our team was able to express those rules and the underlying knowledge graph with only 10,000 lines of code.
I mean, I remember when you first shared that with me. I kind of did one of these. I was like, wow.
Yeah. But it turned out I had experience before when I was at Intuit, pushing knowledge graph technology toward inside TurboTax. We also did some of those before and after.
Mm.
Before we use a more procedural language. After, usually it's about actually 100x reduction in code is not a normal. Actually, it's kind of base. So this is where we're talking about the kind of 20x. Sorry, 20x is actually pretty average. Sometimes you can even accomplish 100x. I think what's the idea? The idea is we're so used to be programming. Procedural programming is very easy to learn. You basically translate everything to step, boom, 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 and then for, right? While you're doing that, you're literally trying to manually translate to closer to what machine operates. Instead of assembly, this is just a high form of assembly code, but you still expect the sequence. When you put knowledge graph and put rules, it's a reverse. You declarative programming is about specifying what you want to declare instead of the how. How the machine or the underlying engine, like the relational engine, will take care of it. Given that what you want, we can figure out the best sequence to execute your instruction, the rules. And that's why if you don't have to worry about those precise sequence, then your code is much cleaner, much shorter, and much understandable. Actually, you just specify the rules. What are the control variable? What are the min and max? I don't have to iterate through everything to that, right? In some sense, declarative programming is already present in a lot of the language today. Well, SQL is declarative, but we also take that to the next level, right? You can see Excel sheet programming, macro language is declarative. You don't see for loop, they do a sum. And a lot of those are similar, capture that. So there's a reason such a simplicity and then rules-driven things will make your program much compact, understandable, but also much easier to maintain instead of you have to worry about a brittle code base of 200,000 lines of code. And oftentimes, depending on the technology you use, maybe out of date, suddenly that code is very hard to maintain and move forward and even add any changes.
Yeah. So one of the things that, and you can go in any direction you'd like with this one, but when you say, so when we first started talking about this and you helped me understand that, where my mind goes rather quickly is that sounds like speed. That sounds like agility. That sounds like pace, right? Which is always exciting in a business of any size.
Mm.
And now you're hearing a lot of folks talking about, the role of autonomous workflows and
Mm.
enterprise AI agents. And so if you start connecting what you just unpacked with this notion of workflows that AI agents within an organization can execute against, you start to realize why folks like us get so excited about this,
Right.
because it can go in a lot of different directions.
Yes.
But curious, if
Yeah.
you have any thoughts on that.
Right. So again, in the world of Gen AI agents is really about, by definition, is each AI agent is very focused on one specific area, right?
Yep.
But the general task may involve multiple of those engines can need to be orchestrated in order to accomplish what you want. So in the case translate to what we're doing here is, first of all, multiple agent is a reflection of you need multiple AI workload in order to solve a particular problem, right? So for us, I talk about knowledge graph, building a knowledge graph layer. I talk about the ability for you to actually specify, transform from using declarative language to transform from a knowledge graph representation to a mathematical optimization formula. And that's called prescriptive analytics. For people don't know about it, it's all about optimization. It's not about not just presenting all your data. You make the decision. We make the decision for you. Based on these constraints, we do the mathematical optimization. We show you this is the best way to run your thing. Already laid it out. So that's the one kind of AI workload. There's other kind of AI workload could be using predictive, which is machine learning. The new area is GNN, graph neural net, and can
Yes.
fully take advantage the knowledge graph, the intricate relationship among them, automatically explore the relationship, so greatly reduce the complexity of feature engineering, and make sure the actually machine learning model is now more effective because it does not have to relearn the things we already know about how these data related, more focus on the patterns we have not seen, right? And last but not the least, also the seamless integration with Gen AI. So when we look at all these, I think the multi-engine AI orchestration also need to depend on a very sound or foundational knowledge graph layer. And then with those AI workloads already available, now the question is, for each AI workloads, you do one thing really well, optimization. The other one is prediction really well. The other one is analytics really well. How do you actually match them together so you provide the ultimate answer? This is where the ultimate AI is.
Yeah.
There's no boundary. You just ask AI, say, I want to do this. Underneath, they tease apart this, but then say, oh, already you have a knowledge graph. Run this workload, run that workload, and put things together, then produce the final answer.
You took that apart and put it back together again so well, Jay. I appreciate that, because I think that there's just a lot of enthusiasm
Mm.
around all these different territories, but it can be difficult for a variety of stakeholders with a variety of different type of technical quotients, including the CEO. And so something that I would love for you to share your thoughts on is, again, the pace with which things are moving. The opportunity is so significant, yet there are a lot of things to consider, especially when it comes to mission critical and what we've just discussed. So How do you feel the CEO's role has evolved within the context of these significant technical investment decisions? And just some general thoughts on that, because I'm starting to read and hear a lot more perspective on the evolution of that because of how powerful these systems can become when harnessed properly.
Right. I'm not a CEO, so I cannot really direct address that, but I'll try my best. So for me, I don't expect a CEO at a big enterprise can know all these technical details at this level. That's just reality. But the CEO, usually a great leader, knows about finding the best people with the right experience to trust them, empower them. But at the same time, CEO can do sanity check, even from a business sense. I think more about, is there a holistic view towards Gen AI? Is there a holistic plan? Instead of you talking about this piece of technology, this POC, can these connect it? Can I see the big picture, how these things connected? But also translating to how you evaluate technology. Are you just looking for a fit for purpose, small and very narrow focused technology? Or are you looking for some technology can allow you to integrate many things together so that shorten your path to experiment, to actually go to the next level for production, versus you have to figure out, I have this point solution here, point solution. Now I have to figure out how to integrate them together. I would say the winner is the one can go to market faster than anybody else. If you can leverage those technology already give you the integrated view, and then already integrate multiple AI workflow together, I would say that you'll run much faster than the other one. And cost-wise also is going to be lower relatively, because imagine, again, that's a silo problem. You have individual Gen AI app or effort, or you have, predictive analysis, each one its own silo product. You're trying to find the best, and you try to figure out how to mesh them together. I would highly recommend think about holistically, how do we integrate all these things together from the get-go, and try to find the technology can fit that. And I believe if your data is in Snowflake, we do have the solution for that. At least one of the few companies in the world can offer that.
Well, absolutely, facts. So on that, Jay, this is the last one. You wrap it up. Anything else you want to add? I think this is a fantastic conversation. I'm so glad we got not 8 minutes, but we're into 42 minutes here. So anything you want to say before we wrap this thing up? And I just want thank you.
This is a fascinating area. Thank you, Alec. Again, what I present is my own view. And I'd love to discuss with anybody who have better ideas, more experience, but we're all working together, try to unpeel this huge, orange, but also try to figure out a way how to leverage AI in the right way to solve for the right business outcome. And that's what we're here for.
I love it. It's so true. And it's such a pleasure working with you, Jay. And I appreciate all your time and all your perspective. And I can guarantee that the CEOs that watch this are going to get a lot better, and everybody else that watches as well. So thank you so much for your time.
My pleasure.
We'll see you.
Okay, bye.
Bye-bye.